Today we're going to be describing and graphing transformations of the absolute value parent function. We're also going to graph combinations of transformations. So let's just start with the absolute value parent function. It looks like this: y equals the absolute value of x. For the key points, we're going to start with x values -2, -1, 0, 1, and 2. And when you plug each of those x values into the absolute value function, you end up getting positive y outputs. Okay, so those are the key points we're going to use. Remember, the parent function for the absolute value has a V shape. For our vocabulary word bank, many of the transformations we've already discussed have been vertical transformations, which change the y values. So a reflection in the x-axis is also called a vertical reflection. Vertical stretches and shrinks will cause the graph to narrow or widen. And then translations up and down shift the function up or down so many units. The only horizontal transformation we've discussed has been a horizontal translation left or right so many units. Remember, because it's horizontal, that's going to change the x value. Here's our general form of the function. When a is bigger than 1, that's going to cause a vertical stretch. So an example of that might be a function that looks like this. See how 2 is the a value out front? That would cause a vertical stretch because that a value is bigger than 1. If a is between 0 and 1, there's going to be a vertical shrink. So an example of that might be a function that looks like this. Notice the a value out front is 1/2, which is a number less than 1 but bigger than 0. So it would cause the graph to shrink vertically. Okay, and if you have a negative sign out in front, that's going to cause a vertical reflection, also called a reflection in the x-axis. So an example like that might be -3, absolute value of x plus 2 minus 10. Look at what we have out front. See how we have this negative sign out front? That's going to flip the graph. All right, so we're done with this section. Now we're going to move inside the absolute value bars. Remember, anything inside the absolute value bars is a horizontal transformation. It's almost opposite of what you think, right? Horizontal transformations are weird. It's almost opposite what you think. X plus h is going to be a translation left h units. So an example of that might be, let's do this first example, 2 absolute value of x plus 3 minus 1. Do you see how the x plus 3 inside the absolute value would indicate a shift left? Versus if you have x minus some number, that's going to be a translation to the right. So an example of that would be our y equals 1/2, absolute value of x minus 1 plus 5. You can see inside the absolute value bars we have x minus 1. That would be a shift right 1 unit. Okay. Then I go back outside the absolute value bars for our plus or minus k. Remember, anything outside absolute value is vertical transformation. Anything inside is horizontal. So plus k is going to be just a translation up k units, whereas minus k is going to be a translation down k units. So some examples. Up might be our 1/2 x minus 1 plus 5, because you see how the plus 5 back here would move the graph up 5 units, versus a transformation down or a translation down. We could use this -3 absolute value of x plus 2 minus 10. You can see the minus 10 out back would cause the graph to shift down 10 units. Remember, anything inside absolute value or parentheses is a horizontal transformation, where anything outside the absolute value or parentheses is going to be a vertical transformation. Horizontal transformations change the x values. Vertical transformations are going to change the y values. You can use more than one transformation to change the graph of a function. So in example 4, we're going to be describing the transformations, then checking our work using a graphing calculator. Okay, so you will need a graphing calculator in this section. It says use your calculator to graph the parent function and each of the functions below. Okay, so let's first start on our own. I know that the parent function here is absolute value of x because I see the absolute value bars. So how are each of those functions different? What transformations have occurred? Let's go through each one of these. Let's start with the minus sign out front. That is going to be a vertical reflection, or you can say that it's a reflection in the x-axis. Okay, what comes next? The x plus 5, that's horizontal because it's inside. So I'm going to say that that is a translation, and actually we can even say horizontal translation. I'll abbreviate horizontal with H-O-R-I-Z, horizontal translation. That would be left 5. And then number 3, the minus 3 out back, that is going to be a vertical translation down 3. Okay. Now, comment really quick about combinations that you want to make sure you know is that order matters. Order matters, so important. So when you list these 3 transformations, you want to make sure that they're in that exact order. If you write them out of order, you could be wrong. To make sure that I always write them in the correct order, I start on the left-hand side and work my way from left to right. So you can see I saw the negative first, then I saw the plus 5, and then I saw the minus 3. If you work your way from left to right, you're not going to be wrong when you're listing out those transformations. Okay, so let's list out the transformations in part B, working our way from left to right. Okay, the first thing I run into is the minus, so that is going to be a vertical reflection. In the x-axis. Number 2 is I see 4. 4 is a number greater than 1, so that's going to be a vertical stretch by 4. Then we move inside the absolute values, that's horizontal something. Is it going to be a horizontal translation left or right? Minus 1, it's opposite of what you think, so it's going to be right 1. And then the last thing I see is this plus 2 out back. It's outside absolute value, so it's vertical. It's going to be a vertical translation up 2. Okay, so now go ahead and get out your calculators. Okay, now we're going to learn how to use the graphing calculator. So I want you to go into y equals. We're going to graph the parent function first. To do this, we're going to go to math, arrow over, so that NUM is highlighted, and see how there's an absolute value selection there. We'll press enter, and you should see absolute value bars pop up. And we're taking the absolute value of x. Okay, your variable is right here. It's this button. And then you can arrow over to the right. There's the absolute value of x. Press graph. And there's our V shape we were looking for. If you don't see this graph, I want you to go into Zoom and just select Zoom Standard, and your graph should look like mine. Okay, we're going to compare this parent function to part A. So in part A, we saw negative absolute value of x plus 5 minus 3. So the first thing we have to type is a negative. Just be careful of which one you use. If you look down here at the bottom, there's a smaller negative sign and then a larger negative sign. We use this in front of constants to make them negative, whereas this is the subtraction symbol. So we're not really using a subtraction symbol here. We're going to use this little negative sign in front of our absolute value. Make sure you use the right one or you'll get an error message. Okay, so we have -1. Then we have to do absolute value. So I'm going to go math, number, absolute value of x plus 5. Use your variable button. Arrow over to the right to get out. If you have an older calculator, at this point you'll have to close the parentheses. Otherwise it won't graph correctly. Okay, and then -3. Graph. And it looks to me like it's been vertically reflected, flipped, right? That's the same thing as a vertical reflection. Not only has it been flipped, but it's also been moved to the left and down. What did we get? We said vertical reflection, horizontal translation left 5, and vertical translation down 3. So it does look like it's been moved left 5 and down 3. Okay, let's graph the other one now. Go back to y equals. I'm going to clear out my y2. So I'm just pressing the clear button in this top right hand corner. Then I'm going to type in -4. Again, use the smaller negative. And then we'll do our math, number, enter on absolute value, type in x minus 1, arrow over or close your parentheses, and then do +2. Now notice right here when I did x minus 1, that is when I used this negative symbol over here. Okay, so just be careful. Press graph. There's our parent function. There's our transform function in red. So it looks like, again, that we have flipped the graph, which we had over here. Let me see if I can make this any wider. There we go. Okay, over here we said vertical reflection. We also said vertical stretch by 4, which is why the red graph got more narrow. We also said vertical stretch by 4, which is why the red graph got more narrow. We see a horizontal translation to the right 1 and a vertical translation up. How many units would that be? Up 2 units. Okay, so that all checks out. All right, so now we're going to graph combinations of transformations on our own. I always start by filling out the parent function points, the -2, 2, -1, 1, 0, 0, 1, 1, and 2, 2. That's for our parent function, absolute value of x. I know to use that parent function because I see the absolute value symbols. Let's go ahead and write out our transformations. We work our way from left to right. So what is my first transformation? What's the 2 represent? That's going to be a vertical stretch by 2. Okay, and what's that going to change, x or y? That's going to change your y values because it's vertical. Okay, what's my second transformation? Inside absolute value bars, so I know it's going to be a horizontal something. Is it left or right? Horizontal translation, that would be right 2. Is it going to change your x or y values? It's horizontal, so it's going to change our x values. Okay, and then last but not least, we'll do this in, we'll do pink. Third transformation is the +1. It's outside of the absolute values. I know it's vertical. That's going to be a vertical translation where? Up 1. And again, it's going to change the y values because it's vertical. Okay, so now I'm going to take my parent points and transform them. So I always go in that order, 1, 2, 3, from left to right. So I'm going to start with my vertical stretch by 2. Okay, so vertical stretch by 2, that changes the y value. So I'm going to multiply the y values by 2. 2 times 2 is 4, 1 times 2 is 2, 0 times 2 is 0, 1 times 2 is 2, and 2 times 2 is 4. Okay, so that's done. Then I'm going to do my step 2. That's horizontal translation, so that's going to change my x values. So I'm going to take my x values and do what to move it right to? I'm going to add 2 to move it to the right. Remember, horizontal stuff's weird. See how it's different than what you see in the formula? It's opposite of what you think. Okay, so I'm going to add 2. Negative 2 plus 2 is 0. Negative 1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. And 2 plus 2 is 4. Okay, we're still not done yet. We still have to do our vertical transformation. So vertically, we're going ahead and moving the graph up. So up 1, we're going to do plus 1 over here. 4 plus 1 is 5. 2 plus 1 is 3. 0 plus 1 is 1. 2 plus 1 is 3. And 4 plus 1 is 5. All right, and that's it. Okay, so now let's plot those points. I'm going to plot the point 0, 5. I'm going to plot the point 1, 3. I'm going to plot the point 2, 1. I'm going to plot the point 3, 3. And I'm going to plot the point 4, 5. Okay, it does look different than the original absolute value parent function. It's a little bit more narrow, and it looks like we would have shifted that origin point to the right 2 and then up 1. So that looks good to go. Okay, same process on all of these. Transformations, we want to make sure that we label them in the correct order. So number 1, we see 1/2 first. It's outside of the absolute value, so I know it's vertical. Is it going to be a stretch or shrink? It's going to be a vertical shrink because it's a number less than 1 but bigger than 0. Make sure you put the by 1/2. You need to know the scale factor. Okay, step 2. We have x plus 1. It's inside, so that's going to be horizontal. Is it going to be a horizontal translation left or right? Left 1. Okay, and then last but not least, we've got this minus 2 outside of the absolute value, so I'm going to say it's vertical. Is it a vertical translation left or right? Left or right. Is it a vertical translation up or down? It's a vertical translation down 2. Okay. Let's fill out our chart with our parent points. Negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2. Okay. And then we're going to make sure we do our transformations in the correct order. To vertically shrink by 1/2, we see the word vertical, so that's going to change our y values. I'm going to multiply by 1/2. Half of 2 is 1. 1 times 1/2 is 1/2. 0 times anything is 0. 1 times 1/2 is 1/2. And half of 2 would be 1. Okay, so that is done. Then we move on to the horizontal transformation. So for horizontal transformation, what changes, x or y? Here the x values are going to change. To move it left 1, we're going to use minus 1. Okay, so negative 2 minus 1 would be negative 3. Negative 1 minus 1 would be negative 2. 0 minus 1 is negative 1. Then we'll have 0 and 1. Okay, that's done now. Last but not least, vertical translation down 2. It's vertical, so that changes our y value. Down 2 would be minus 2 from all my y values. 1 minus 2 is negative 1. Half minus 2, what would that be if you had 0.5 and you subtracted 2 from it? That's going to be negative 1.5 or negative 1 1/2. 0 minus 2, again we see 1/2 minus 2, and then 1 minus 2. All right, so there we go, and then that's completed. Again, order is so important. Make sure, well, you can think about PEMDAS really. Make sure you're always doing your multiplication before any addition or subtraction, right? Multiplication always comes before addition and subtraction. So that's why order is so important here. Okay, so then you would have your points, the negative 3, negative 1, negative 2, negative 1.5, etc. Okay, let's list our transformations. Make sure you list them in the correct order. I'll color code these again. Let's go ahead and grab that blue back. Okay, number 1, what do we see come first? The negative sign. So that's going to be a vertical reflection. In the x-axis. Okay, then what comes next? The 3. 3 is a number bigger than 1. You're thinking about it as a separate transformation from the negative. Okay, so is it going to be a stretch or a shrink? Because 3 is bigger than 1, it's going to be a vertical stretch by 3. You have to put the scale factor. Okay, and then number 3, we see x plus 2, which is inside the absolute value. So that is going to be our horizontal translation. Is it left or right? Left? Left 2. All right, let's fill out our parent function key points here. Negative 2, 2, negative 1, 1, 0, 0, 1, 1, 2, 2. Start with the vertical reflection. Vertical is a change in y. So I'm going to multiply by negative 1 to get all the y values to have the opposite sign. So we'd have negative 2, negative 1, 0, negative 1, and negative 2. Okay, so that's done. Vertical stretch by 3. Again, it's vertical, so that's changing y. Vertical stretch by 3, so I multiply by 3. We get negative 6, negative 3, 0, negative 3, and negative 6. Right, and last but not least, we have horizontal translation, left 2. It's horizontal, so that changes your x value. Left 2, we're going to go minus 2 to move it to the left. It's weird, remember, see how it's opposite of what was originally written? Okay, negative 2 minus 2 is negative 4. Negative 1 minus 2 is negative 3. Here we'll have negative 2, negative 1, and 0. All right, and that's how we fill out the chart. Again, your ordered pairs are the outermost numbers. So, for example, you'd have negative 4, negative 6 as an ordered pair, negative 3 as an ordered pair, negative 2, 0 as an ordered pair, and that's what you would graph. Okay, last one. Transformations. We start with the negative. That's going to be a vertical reflection in or over the x-axis. I always say in the x-axis. That's the correct terminology rather than over the x-axis. Okay, number 2, we see plus 2. That's also outside of the absolute value, so I'm going to say it's vertical. What kind of vertical translation is it? Up or down? Up. Okay, cool. Let's go ahead and fill out our parent points. Okay. That looks good. All right, and we're going to start with vertical reflection. To flip all of the whole function over the x-axis, we're going to have to multiply the y values by -1. So that's done. And then in order to get a vertical translation up 2 to occur, we are going to need to add 2 to all of the y values. Okay, and there we go. Those would be our ordered pairs: -2, 0, -1, 1, 0, 2, 1, 1, and 2, 0.